Hello everyone, my name is Isaac and welcome to my vacuum reactor tutorial. If you saw my previous video on the vacuum reactors, that design that I showed off actually ended up having a couple issues that I only discovered after the video was posted and after I've gotten some feedback from some people. So this design, I hope, fixes all those issues that the previous design had while still maintaining a relatively compact and cheap option for power in early EV and IV. These reactors behind me, these are what got me through LUV before I got fusion power eventually. And while I'm not using them anymore, I felt a little bit bad about leaving a vacuum tutorial that had some obvious issues to it up, and so I came back to redesign the reactor, and that is what this video is going to hopefully accomplish. So this video is going to have a few different parts to it. The first part, I'm going to briefly explain the differences between this old reactor design and my new and improved one. Then I'm going to go into a bit more of an in-depth explanation on how vacuum reactors work in general. Then I will talk about this specific reactor and all the different pieces of it. And then finally, I will go into a full build tutorial in a creative world to show you how you can build one for yourself. So without further ado, let's get into it. So this is my new vacuum reactor design. This is right beside this old one. So this is the one that I showed off in the previous tutorial. And this is the new and improved one. As you can see, they look very similar. There's just a few minor differences up here. However, the big differences are down in the control circuit. So this is the control circuit for the old one. It's very small, very compact, but unfortunately it is flawed. And so that's what this new and improved control circuit is hopefully going to accomplish. This one, a little bit more complex, but as far as I can tell, the main issue with this previous design is that even with IV conveyors, even with trying to do everything perfectly, if you're moving coolant cells in and out of the reactor while it's on, there's always a chance that you're going to get core temperature increase. I couldn't find a specific reason for it. It just seems to happen randomly. It's very hard to catch, it's very hard to debug, and so this new design is meant to fix that. The main feature of this new design is this right here. This is the timer. It's the big item for this new design, along with these repeaters to help space things out. The base of the previous control circuit is still here. We still have the NAND gate with the different inputs, and we still have the tally box, star of the show, which allows this vacuum reactor to function and to automatically replace the fuel rods when they're depleted. So what's so good about vacuum reactors, and why should you build one? Well, one of the main points of this one specifically is how compact it is. It is simply a 3x3x6 for the main reactor unit, and then the control circuit down here is a 5x8x3, I believe, and it's completely remote, so you can put that wherever you want. It's quite a lot of power output for such a small footprint. As you can see, if we turn the reactor on, 43,000 EU a tick. That's very good for EV when you can build this, and it even holds up in IV and a little bit into LUV. So the power output for it is very good. Another perk to it is that it is very cheap to set up. The infrastructure cost is very low. All it is a vacuum reactor and a nuclear reactor. Or a vacuum freezer, sorry, I should say, and the nuclear reactor, plus the input cost of the uranium. It's quite cheap to set up. The alternative for EV and LUV players, or EV through LUV, is fluid reactors. Those are another good option. However, the difference between a vacuum reactor and a fluid reactor is a fluid reactor is a lot more expensive to set up initially. The input cost for it is quite high, The turbines that you use to generate power have slow startups for fluid reactors. This one has instantaneous power. As soon as the power's on, you're generating at full power. But one advantage that fluid reactors do have is that they are more efficient on uranium. They produce about twice as much power per uranium input that you have. So that is one thing to keep in mind. So now I'm going to just briefly explain how vacuum reactors work for those of you who haven't seen it before. So in the nuclear reactor, we have these fuel rods and we have coolant cells. When the reactor is turned on, these fuel rods generate power, but they also generate heat, and that heat has to go somewhere. And so all of these coolant cells take heat from adjacent fuel rods, and they start storing heat. The way that we get rid of the heat is that something extracts the coolant cells. I'll just do it manually to show you. Puts them into a vacuum reactor. The vacuum reactor cools down the coolant cells, and they get cycled back in to this buffer, which then replaces them inside of the reactor. If you just want a very basic reactor, vacuum reactor, this is the way to do it. However, it is not completely safe. You will eventually get heat gain if you run it for long enough, as well as it doesn't automatically replace the fuel cells. And so that is what my design accomplishes. It prevents heat gain and also replaces the fuel cells automatically. We are now going to go over the logic circuit for the reactor and how it connects back up to the reactor. So this reactor has 4 inputs to it: this receiver, this receiver, this receiver, and this tally box. These 4 inputs control everything about the reactor. This one is just a simple power indicator. Whenever we need power, this is going to turn on and it's going to allow the reactor to run. This is a heat indicator. So as long as the reactor has less than 5% core heat, this will be turned on and allow the reactor to run. If it ever gets above 5%, this will shut off and hopefully prevent your base from exploding. Not that it should gain heat, as far as I can tell. This one is just a simple master switch. So if you have it on over here, the reactor won't run. You can just use this to, if you ever need to make changes to a reactor or anything, for any reason that you don't want the reactor running, feel free to turn that on. And finally, the star of the show is this tally box. This remote comparator is hooked up to the reactor, and this tally box has a runic whitelist in it with 40 quad fuel rods. That means that as long as this reactor has 40 quad fuel rods in it, it will allow that this redstone to turn on and the logic to run. So how does that help us? Well, after this goes through the entire life cycle of the fuel rod, they will turn into depleted fuel rods, and then it's actually a different item ID from filled fuel rods. So once they turn into depleted ones, the reactor will no longer have 40 depleted fuel rods, they will no longer have 40 fuel rods in it because they will be depleted, which will allow the logic to change the depleted fuel rods with fresh ones. So those are the 4 main basic inputs. The new things that were added with this design is this timer right here. As you can see, the timer is about to click. When the timer clicks, this, which controls whether the reactor is turned on or off, shuts off briefly for about 6 seconds and then turns back on. So that is the main difference between this previous design, and this new design, is that every 75 seconds, the reactor will shut off and allows the coolant to be extracted out of the reactor. So this design no longer hot swaps coolant. It does not extract coolant while the reactor is running. It shuts the reactor off briefly, extracts the coolant, cools it down, puts it back in the reactor. And so that's what all this logic here is for. Every 75 seconds, it allows the reactor to shut off, the coolant to come out, and the reactor turns back on, there's no coolant being extracted while the reactor is running, which should prevent any heat loss. Okay, now welcome to my creative world. Here we're actually going to be going through and building the whole thing. As you can see, I have one built already here, so we're going to be taking it step by step to see how we can build it here. My previous design, or my previous tutorial, showed off two different designs. It was an EV1 and an IV1. This one I'm only going to be showing off a single design. It's able to be built in EV, and it produces EV or IV power, so you can follow this no matter what stage you're on. So let's jump right into it. To start, we're going to build our vacuum reactor as normal. There's nothing too important about the placements here. I'm going to be using an auto taping maintenance hatch just to show off for example. You won't have access to that, but feel free to use any kind of maintenance hatch you want. Let's grab some tools here. The only important things, this is a non-working wrench, whoopsies. There we go. So the only important placements here are we need the output bus on the bottom and we need the input bus on top. Everything else can kind of go wherever. I'm going to place the energy hatches here. We'll be using 2 EV energy hatches just so that this build is completable in EV. If you're an IV and you want to use one IV energy hatch, that also works. Moving on, we're going to build the actual reactor now. So that will go right here. Place the center block and the reactor chambers surrounding it. Next we'll place the thermal monitor there and chest there. Now we will go on to the coolant system, which allows us to move the coolant around, and the control rod system. We need one item conduit right here. We need one item conduit right here. Next we'll put a redstone conduit, an insulated redstone conduit there, and 2 insulated redstone conduits there and there. Next important thing is the high voltage chest buffer. You can use any kind of chest buffer you want, but I just made a high voltage one. The important thing about this one is that we want it facing down, just like our last design. If it's not facing down, we're going to have issues with if it's facing here, for example, the coolant is going to be going into here no matter what you do. So we want it facing down, and we want a machine control cover on the back here, and we want an EV conveyor module. EV works perfectly fine. You don't need to worry about using an IV one facing into the reactor. So now this one is set to use processor machine state with an export. And the control cover is, let me just double check with this one. It is a disable with redstone, yes. Okay, disable with redstone. Very important that you get these right, because if you do not get them right, it can cause the whole thing will probably just fall apart. Let's see. Next, we're going to set up the filters. So one of the major improvements over the last design is that we're using Ender IO item filters now. We put these on extract. These will be set to active with signal. We want this to be set to 75% extraction, and we want these both turned off, and we want that for both of them. Another thing that I like to do is I like to add these item speed conduit downgrades. I don't know if they actually do anything, but it just makes me feel a little bit safer. I'm going to get one coolant cell from here, and we will set the filter to only extract these. Next, this guy is just going to be set to input. Nothing else exciting with that. And finally, this here, we're going to disable the connection here, we're going to set these guys to both insert and extract. This one we're going to set to extract only whitelist, and then we're going to look up a depleted fuel rod, depleted uranium fuel rod. Set that to be whitelisted and only active with signal. Or should it be the other way around? Let me just double check that. Active with signal, yes, okay. Next, we're going to do something very similar over here. Make sure that is set to insert, put in another filter, and this one is going to be a full fuel rod. Just like that. Active with signal, and that should be all of the item conduit setup. Okay, we will now go on to building the logic circuit. So, the logic circuit all centers around this NAND gate. We'll be going through one by one with the wireless transmitters and receivers to show you exactly how they connect up. So the first one we're going to be putting down is the power control. This one is going to hook up to your central power storage, and whenever it is running low on power, we are going to send a signal here to the, just needs to update, there we go, to the reactor control switch and tells it to turn on. The next one we're going to do here is the heat control. So as long as this thermal monitor is saying that heat is below 5%, then this is going to allow the reactor to run as well. You need to make sure that the heat monitor is set to high, then low, and that will invert the signal, which will allow this to turn on. Next, we're going to just set up a classic manual override shutdown switch. So you can put this anywhere you want. I'll just set it up here. As long as this is turned on, then the reactor will shut off and not run. And then for the final input, I'm going to go over here and I'm going to grab the magic box. So the way you want to set this up is the tally box goes directly above the redstone right there. The remote comparator goes directly on top of the tally box. This runic whitelist, place 40 fuel rods into the runic whitelist. Unclick ignore quantity, and then double click both ignore metadata and NBT. That goes into the tally box now, and that will allow us to control it. However, it can't see the reactor right now, so you take your crystalline eye, click it onto the reactor, or I suppose shift click it, and then you can place it into the remote comparator, and we'll now see that if you put 40 fuel rods in there, this turns on just as we want. If there's 39 fuel rods in there, it doesn't work, it turns off. It has to be 40 or more, which will never be more than 40, but so that is working as intended. Next, we're going to just set up some redstone here. We want one redstone torch there. I think I'm actually missing a redstone torch, so I'll just cheat an extra one there. One redstone torch there, and one redstone torch there. The redstone is going to be looking like this. We want one here, 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 and here, and then a redstone here and a redstone there. Next is the major improvement here. It is the timer. So this design that I'm showing you right now, if you're only in EV, the 360 coolant cells are going to be the best ones you can make. If you're in IV and you can make these 540 space coolant cells, I recommend doing that. It'll allow you to run the reactor for longer without needing to shut it off. But since we're just in EV, I'm just going to show you the EV design. We're going to be using these 360 coolant cells, and that means that the timer is going to be set to 55 seconds. You can adjust it a little bit more, a little bit less, depending on if you want to make it more efficient or whatever. But for EV, I recommend 55 seconds. For IV, if you have the space coolant cells, you can go about to 80. If you have different coolant cells, you just need to adjust this timer, and that will control how often it turns on and off. Next, we're going to take the repeaters, place one right here, one right here, one right here, and one right there. These one we're going to set to 64 ticks. You can see my Wayla in the bottom right, 64 ticks. This one is also going to be 64 ticks. This one is going to be 4 ticks. And this one is going to be 32 ticks. I think. Let me double check. Here. 64 ticks, 64 ticks, 4 ticks, 32 ticks. Perfect. Okay, next we're just going to put a NOT gate here. And then we have the final receivers and transmitters. So this next receiver is going to go here, and that is actually going to hook up right to here. So when this is turned on, of course, it never updates immediately when you press it. When this is turned on, we're going to call this one rod control. So as long as you have 40 rods in here, or I suppose it's inverted, so if you do not have 40 rods, this is going to be what turns this on. And that is going to hook up to here, which disables this section here. We also want that rod control to be going through here. And you need to click this one. Actually, I should have done this earlier. Make sure that this cable right here is facing into the chest buffer, and it's also facing up, so that when you place the receiver, it connects to it. Rod control. There we are. So we want rod control here, and the transmitter right here. Next, we are going to be placing down the coolant control, coolant extract. If this light is on, that means that this receiver will be on. And this receiver also needs to connect up like that, and that will allow coolant to be extracted. But only when this is on. And then finally, the last pair, this is the reactor control. This is what turns the reactor on and off. And this is important. You cannot have this reactor control facing into the top block. That is because these blocks actually carry redstone signal. And so if this is turned on, then it's going to power this item conduit, and it's going to allow it to extract because this is active with signal. So you need to make sure that the receiver is not pointing into that. Reactor control. There we are. Okay, I think that is all the blocks placed down. Next, we're going to set up the reactor. Now we are going to show off how to actually set up the reactor. So this design for the reactor is straight off the wiki. It is, I think, the most efficient packing you can get, which means the maximum power generation for the fuel rods. Here, 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 and there. So now we put in the fuel cells. There we go. This is designed for the reactor. Let me grab a lever. Don't have one in my inventory. There we are. So now, if we turn this on, we can see we are generating power, and these coolant cells are filling up with heat. One of the important things about a vacuum reactor is that you really want these coolant cells that gain heat at the same rate to be offset from one another, so that you don't overload your freezer. So as you can see, this design is like mirrored on a diagonal. So this one has the same heat gain as this one. This one has the same heat gain as this one. This one has the same heat gain as this one. You want them to be offset from each other so that so that they both don't need to be extracted at the exact same time. So we're going to be running this for a little while, and I'll show you how to offset them. In the meanwhile, why don't we set up the power here? So this is going to be running off purely EV. Extracting using EV power is actually more efficient slightly than extracting with an IV cable, because however much gets pulled out is dependent on the cable type. So if you use EV, that's a little bit better than using IV. There we go. Make sure this is turned on. There we are. And let me shut off the reactor. So the optimal time to extract them, the optimal time for you to extract these coolant cells is at 63%. So we wait till this one reaches 63, turn off the reactor. Since this is at 63, that is perfectly offset from its neighbor. Oh, I forgot one very important thing, is to fill this up with any excess coolant cells that you have. Just like that. Once one of the heat cells reaches 63, then you want to take it out. This is not set up properly. There we are. And now that should be able to run. So as you can see, these ones are almost at 63. Just a few more seconds here. And there, turn the reactor off. Take it out. This is now offset from the other one perfectly. We can put this into the reactor to cool down. So do this with every single heat cell. Make sure that the one that it's opposite to is offset by 50%. And I'll come back when I'm finished with that. We are back, and as you can see, all of the coolant cells are offset from one another. They're not perfect, but they don't really need to be perfect. As long as they have a decent offset, that should be good enough. I want to show the reactor in action here, so we'll be watching this timer. And once this timer flips, about 3 seconds later, this is going to shut off, and we're going to see it in action. Are there any cells in here that actually need extracting? Maybe not the best example, but we can maybe see something. So here it comes, and the timer clicks. The repeater delays it for a second. If we look in here, reactor turns off, coolant cells get extracted, reactor turns back on, and we are running smoothly. Perfect. So I thought I'd just show you how the fuel rod switching looks. So as you can see in this chest, we have some full fuel rods here, and these guys are just about to tick off. It's in 20 seconds they'll be depleted, and we can see how the switching occurs. Make sure that this timer looks like it's going to hit first, so the timer will go off. This will shut off. Any coolant cells that need extracting will get extracted. Coolant cells go back in, and we have 6 seconds before the fuel rods are depleted. There we go, they're all depleted. They are getting extracted, getting inputted. The coolant cells are frozen, they aren't getting moved around at all. All the fuel rods are in now, all fully replaced the depleted ones, and now the reactor is running again. And the depleted fuel rods ended up here with the non-depleted ones still ready for the next time that the fuel rods get depleted. Okay, so now that you've seen the reactor running, I want to go over a few things that I didn't mention throughout the video. One is that this is a vacuum reactor. It is a nuclear reactor, so if something does go wrong, if you don't build it correctly, or if something crazy happens with the server, it can explode and destroy your entire base. So please, if you're playing on single player, make sure you have plenty of backups. If you're playing on a server, use proper protection, use warded blocks to block it off or any sort of blast resistance. Make sure that this does not have the possibility to completely wipe out your playthrough. Please. Another thing is, make sure it's all built in a single chunk. We don't want chunk loading errors. So as you can see, everything here is built within one chunk. This is all within one chunk. If one of these things is not loaded, it has the possibility to go wrong. And another thing is that this control circuit does not have infinite range. It can have infinite range if you hook up the receivers in a slightly different way. The main thing that doesn't is this remote comparator only has a range of 20 blocks. So you could probably find some place to fit this within 20 blocks of your reactor, but if not, just set up an additional like wireless transmitter receiver pair hooked up to the comparator so that you can put it wherever you want. And another disclaimer is that this does not have any sort of fail-safes for maintenance issues, or if you run out of power in your storage system and your vacuum reactor shuts off. There's no fail-safes for that built into this design specifically. You can make one if you need put a needs maintenance cover here, and then like hook up some redstone here to shut off the reactor. That's a valid solution. Or if you have a power indicator, there's ways to do it, is what I'm trying to say. There are ways to safeguard against that. I have not run into any issues with it, but depending on what your base looks like, depending on how your playthrough is, you might need to look into making sure that this is always powered and always fully maintained. The only thing that will stop the reactor if this vacuum reactor or vacuum freezer is not running properly is this will run out of coolant cells to put inside the reactor, and then there won't be any coolant cells in here, and so the reactor will gain heat, which will cause this to trip, which will cause the reactor to shut down. So it's not going to destroy your base, hopefully, if the coolant cells aren't being filled, but it's just something to keep in mind. So that about does it for my tutorial on the vacuum reactor. Like I said before, I've been running this particular one right behind me for like 12 full uranium cycles, and it has never gained any heat. It hasn't given me any problems. So as far as I can tell, with the removal of the hot swap from the previous vacuum reactor design, this one is now completely safe. But as always, just be careful. It is a nuclear reactor. If you don't build it correctly, or if something goes wrong, you could have a serious problem on your hand. But if everything goes right, you can have a very nice and cheap power source to help get you through some of the mid-game. If you have any questions about this, because I'm sure I forgot to mention some aspect of this design, if you have any questions, feel free to leave a comment, or if you have a really pressing question, message me on Discord. I'm in the GTNH Discord server, so feel free to message me there or DM me. I don't check the comments for this channel very often, but if you ping me on Discord, I'll definitely be able to see it, and I can hopefully clear up any questions, or in fact, probably the best thing to do would be to leave a comment on the tips and tricks post that I'm going to make, so that if other people also have the same question, they'll be able to check the comments and see. But other than that, I think that's all I have for you, so thank you very much for watching. I hope that you can get some nice, easy power off this design, and maybe in the future I'll make more tutorials. Thank you for watching.